I'm going to present our morphological analyzers and our named entity recognition component for Lucene and Solar. First, a few words about Introfind, the company I'm working for. We offer products in the field of search and search-based applications. Our products are partly based on open source, especially Lucene, and on in-house development. We have, the company was founded in the year 2000. We have 2 Lucene committers within the company, 20 employees currently, and we have about 700 customers or installations in mainly in German-speaking countries, and we do this big number of installations by our partner network. So we have companies in the field of document management and archive systems vendors who have integrated our search component, our search products. So what we add to Lucene and to Solar is we add, well, mainly text analytics and information extraction components like morphological analyzers for most European languages, named entity recognition for German and English currently. We have a separate product for text classification. It's automatic text classification based on a statistical approach, like using support vector machines, for example. And we have our own clustering component. So, and today, in this 10 minutes, I want to show you the morphological analyzers and our named entity component, extraction component. So, a morphological analyzer, what does such a component do? How does it compare to stemmers which are available for free open source in Lucene? So a morphological analyzer, it well, consists of 2 components. You have a lemmatizer component that maps inflected forms of words to their base forms. And it also produces word categories. Like in the example here for English, you see from going, it maps going to go, and it additionally says you it's a verb. You have a verb here. So it's like a part of speech tagger. And this may be an easy task for languages like English, where words don't change so much, so you don't have so many inflections in English. But for other European languages like German, French, Russian, and so, you have a lot of words change much more, and you have a lot of more irregular words in these languages. So doing this kind of normalization, morphological normalization, is much more difficult for other languages than in English. And on the right side, I show you some examples for German, like leave maps to laufen, very irregular. Rannte, that means to run, he ran, rannte means he ran, maps to rennen, and so on. Bücher maps to book, to Buch, it means book. And you have another phenomenon in languages like German and Dutch. You have compound words. That means these languages allow that you attach to each other several short words. Like, for example, this word show here, Kinderbuch, it means children's book. So in English you have 2 words typically, you have a noun phrase, but in German it's 1 word. Yeah? And the same for Versicherungsvertrag, which means insurance contract. In German you have 1 word, which is composed of 2 words like insurance, Versicherung, and Vertrag, contract. So you have to somehow decompose these words into their individual components in order to enable well, high recall and precision for search. And a simple stemmer, a simple algorithmic stemmer, it simply well, cuts off some suffixes of words. So like, for example, an English stemmer typically produces go from going by simply cutting off the ing. So what does it probably do to the word king? It maybe also cuts off ing, which is not very reasonable in the case of king. So you need well, special lists about exceptions for an algorithmic stemmer in order to have good results. And I'll show you what happens if we use an algorithmic stemmer and look for my colleague who is called Bernhard Messer. So if you look, his second name is Messer. If you do a search on the Lucene development list, the first result is okay, you get Bernhard Messer, but all the other results are wholly mess of it, messed up. So this is what you get with an algorithmic stemmer. You get high recall, but not a very good precision. And the contrary is true if you have a good morphology.
3.
Okay, thanks. This is an example for a German newspaper. It's a Solar-based search. The newspaper is the Zeit, Die Zeit, the Times of Germany. And for example, if you look at the input, the query, it's buchen. It means to book a journey or so. We have something like 8,000 results. And here, part of a compound, for example. If you look for a very similar word, like buch, it means book, we have 93,000 example hits, completely different result list. And you can see some of those examples here. And a third, very similar looking word, if you look for Buche, it's a special kind of tree. You have 3,000 examples here. So with a morphological analyzer, you get much higher precision. And of course, it helps you to improve subsequent statistical methods. It's better suited as, for example, cluster descriptions. As cluster description, you don't want to have some strange stem. You need a base form as cluster description. You need morphological analysis for having reliable lookup in ontologies or lexicons. And the second component I want to show you is named entity recognition. You probably know what this is. It recognizes some people names, company names, organizations, locations, stuff like that in full text. How can you use it? You can use it as facets. For example, here, I make a search on the Wikipedia, the German Wikipedia, for some microsystems. And the facet person I get, it's a list of nearly all the founders, for example, because these persons occur frequently in the documents that match my queries on microsystems. The same, for example, for Oracle. What I can also do is, we had a talk about named entity recognition and how to use it in Lucene and Solar in one of the last sessions. You can do much more with it besides facets and facets with expert search. You can implement a natural language processing or question answering system. Like if I have the question, who invented the steam engine? It's of course in this example German, wer erfand die Dampfmaschine? I can transform it to a query which contains words like synonyms of invention, invented, stuff like that, steam engine, and I additionally want the document to have a person name very close to that. So a generic person name, a pattern for a person name. And what I get as hit and snippet highlighting,
1 minute, Christoph.
Thomas Newcomen highlighted, and this is actually one of the inventors of the steam engine. Because I insert the tokens of the named entity recognition within the token stream of my main text field. And I insert tokens like, here's a person. That's it.
Very good, thank you very much.